Hey everybody, welcome back. This video is about the inverse square law. To understand the inverse square law, we have to understand the nature of the X-ray beam. When the X-ray beam is created at the anode target, it's created in an isotropic fashion. That means it's created equally in all directions. The X-ray beam is also described as divergent. This means it's spreading apart and becoming less intense as it travels through space. So here's an analogy. A flashlight has a divergent beam, just like the X-ray beam. In other words, the brightness of the flashlight depends on how close you are to the light. When the distance from the light increases, the light spreads out and becomes less bright. This is described as a decrease in intensity. When the distance from the light decreases, the light becomes more concentrated and appears more bright. This is described as an increase in intensity. The change in intensity due to a change in distance is called the inverse square law. So here's what that relationship looks like. When the distance increases between the X-ray tube and the point of measurement, this results in a decrease in the X-ray beam intensity. The opposite is also true. If the distance decreases between the X-ray tube and the point of interest, then the X-ray beam intensity or quantity will increase. The inverse square law affects several aspects of a radiological procedure. Notice that when the X-ray tube position changes, there's several other variables that change. The X-ray beam intensity at the patient is also changing. When the tube position changes, the patient dose changes. And last of all, when the tube position changes, the receptor exposure is also changing. That's the number of photons striking the image receptor. You should know that all of this is assuming we're using a fixed technique, not automatic exposure control. So all of these relationships follow the inverse square law. If we increase the distance, the beam intensity at the patient decreases, the patient dose decreases, and the receptor exposure decreases. Of course, the opposite is also true. If we decrease the distance, in other words, if we move the X-ray tube closer to the patient, the intensity at the patient increases, the patient dose increases, and the receptor exposure increases. I'm sure you'll be excited to know that there is a formula for the inverse square law, and it looks just like this. So how do you use that formula? That's the topic of our next lesson on inverse square math.